Hello, I am back playing some Geometry Dash, and I haven't played it for a while. It's been a long time since the last video, so that is what I was expecting. I'm going to die quite a few times in the early stages, so bear with me whilst I get back in the swing of it. And whilst I play, I want to talk to you about the Riemann Hypothesis. You may or may not have seen last week in the news, Sir Michael Atiyah claims that he has proved Riemann. He was working on a physics problem and then thought, oh, hang on a minute, this applies to Riemann. And he gave a talk about it, but he hasn't published his full proof yet, so it can't be scrutinized and proved or validated or proved that his proof is not valid. Not yet. But if he has done it, then he gets $1 million from the Clay Institute, because it's one of their 7 problems that they put at the Millennium. They said $1 million if you can solve these. So there's a lot riding on it, but probably more importantly for him, the sort of the prestige of solving Riemann is pretty huge. So we're waiting for him to write that up so it can be checked, and then there may be a proof, and he may have got his $1 million. So you might be thinking, well, what is this Riemann hypothesis? And basically, this guy Riemann in the mid 19th century, about 160 years ago-ish, he made this hypothesis. He was working on the zeta function, and the zeta function is a series of a load of fractions that you're adding up, and you add up these fractions to infinity. So you've got an infinite number of fractions, and each of the fractions have got a power, and depending on what the power is, it adds up to different amounts. And although it's infinitely long, a lot of, by putting the power as certain numbers, then it will tend to be one value. It'll go to a limit where it gets closer and closer and closer to that value, and at infinity it gets to that value. So we can work out I thought I had it then. 82%. That I'm pretty happy with that. That's pretty good. Sorry, the zeta function. Yes. So we can work out what that number will be that it adds up to. This is where we get the crazy minus a 12th from. If you've heard of this, if you add up all the numbers from 1 to infinity, then instead of getting infinity, which is what you might think, you actually get minus a 12th. And that's because there's a formula that will work out this limit. And so you don't have to add up all the numbers, and if you do that for the certain power that generates through the zeta function, generates all the numbers 1 to infinity that you're adding up, then it gives you minus a 12th. And this is something that is actually used in physics, so it's not just a weird thing, it is actually useful and it is a thing. So anyway, that's a discussion for another day. So this zeta function, Riemann was interested in, so that was known before Riemann, and he was interested though in when the zeta function equals 0. So he worked out that there's actually an infinite number of solutions to that. All of the negative even numbers give 0, but they're not very interesting solutions. They're called the trivial solutions. And he also realized that if you put complex numbers in as the power, so that's where you have a real and an imaginary number added together, and the imaginary number is when you have square root of minus 1 in the number. So you put those in as the powers, and you can get loads of solutions out, but all of his solutions had x equals a half. Sorry, the real part of the solution was a half. And so his hypothesis is that it's always a half. For every single solution that's not trivial, that the real part of the solution is a half. And it's been tested to several billion solutions, I believe, and they all seem to be like that. But does that mean it's like that forever, or is there one trillions and trillions down the list that isn't? So that is basically the hypothesis, and if it's true, then you can do some pretty interesting things with Riemann, which is why people care about it. So it describes the distribution of prime numbers really quite accurately. So you can make a formula using the Riemann hypothesis and say, okay, let's put the number 100 in, and it would work out the number of primes there are between 1 and 100. and so you could put in 1 billion and it'll tell you how many primes there are. You could put in whatever number you like, and Riemann hypothesis seems to do that quite accurately. But of course, unless it's true, then you don't know how accurate that's going to be higher up. So that would be really useful if that was true, because then it would give you a greater understanding of the primes and might affect how easy it is to discover new prime numbers, which would either be a good thing or a bad thing for cryptography, because a lot of modern encryption codes are made out of really, really big prime numbers. So if you can find them really easily, maybe that's a bad thing, because you could hack the cipher and get people's credit card details. But equally, if you could generate new ones more easily, it might maybe make it more difficult, because you can use bigger prime numbers because you can find out what they are. So it's going to be really interesting. I mean, unfortunately, the general consensus seems to be that he probably hasn't solved it, because although he is, very, he's done a lot in mathematics, and he's won the Fields Medal and the Abel Prize, and so he's, really high up in the list of intelligent mathematicians who've done fantastic things for the subject. But apparently in the last, in recent years, he's put a few things together that have proved to be not particularly true, or he said he's got to prove something, it's turned out to be false. And so it might be that he thinks he's got it, but when he puts it all together, either he realizes or someone else realizes that there's not really anything there. But at worst, then all this has done is made a lot of people talk about the Riemann hypothesis again. And interestingly, where he presented his findings was at a conference or a talk where the whole point of it was of the conference is to inspire the next generation and to sort of talk about things that get these young minds thinking. So what a perfect place to put this forward, and maybe if he hasn't proved it, maybe it will be the inspiration for someone else to have proved it. So that might work out to be something that, okay, he hasn't got it, but he has caused it to happen for other people. So maybe it's inspired you. You should go and look at what the Riemann hypothesis is in more detail, do a maths degree, try and solve it yourself. And talking of solving things, we've done the level. What perfect timing. Well, thank you for watching, and hopefully see you soon. Hopefully it won't be so long until the next time.